So what is a DAX? DAX is a collection of functions. It is an expression. Okay, it is an expression using which we can perform advanced analytics. Okay, advanced analytics. However, we can perform advanced analytics with the direct query mode. You cannot use all kind of DAX functions. Okay, so there are limitations with the DAX functions. So in that kind of situation, how do we deal with that? So in that kind of situation, you will have to use SQL queries. In the source system SQL server, you need to write the SQL queries, or the stored procedure or stored function, you can use it, using which you can manage it. So you might be asking this question, like, there are some DAX functions, we cannot use it. So what are the DAX functions we cannot use it? That and all, we'll take a look at it. So how do we overcome that? Probably we'll take a look at that. Because in real-time scenario, though the manual covers a lot of DAX related functions in Microsoft, right? Learn.microsoft.com website. If you go there, you can see a lot of DAX functions. Okay, we cannot use, so we cannot use all the DAX functions, whatever is available in their manual, because of the limitations. Okay, you might be working with direct query mode, you might be working live connection. Okay, the import mode, there are cases you'll be using import mode, but the situation where the what data volume is very high, we cannot use import mode. We have to use the direct query mode. In that case, you cannot use all the DAX functions. You cannot leverage the DAX functions. Okay, so that and all we will say. But at this moment, let us focus on the interview point of view, and also understand the fundas. Okay, so what exactly DAX? DAX is, as the name suggests, right? So DAX stands for data analytics expression. As the name suggests, it is an expression, right? Using the expression, what we are doing is we can perform advanced analytics with the help of the DAX or the built-in functions that are available as part of DAX in Power BI. You can perform advanced analytics. So the built-in functions are the combination of functions, operators, constants, and so on. Okay. The DAX is not only used in Power BI. Okay, it is used in even Excel and SSAS also, and Azure Analysis Service also, they are using it. So the DAX can only be used to filter or query a physical table. Remember this. You cannot, you cannot delete the record, or you cannot update the record. Okay, so you can filter the data, and you can query a physical table, and also you can create a table. Okay, the virtual tables you can create it using DAX function. So why do I need to use DAX? The answer is pretty simple. Okay, so using DAX, right? So once you create the DAX, once you create a measure, okay, so measure is something like formula. Okay, so in the formula measure or calculated column, when you use the DAX formula, you can reuse it. Okay, let's say you are creating a measure. For example, I wanted to find out the total sales. So sum of sales, that the output of this one, you will be storing it in a variable. That variable is nothing but your measure. So what you do is, in the Power BI desktop, you go to the modeling tab, and here you can create the measure. So in this case, I don't have the data set. Okay, let me use this. Let me open the previously created one, so that we can save time. you can reuse the DAX formula. So you know very well the function when you create any custom function. We discussed as part of the power is getting power. So in the case of custom function, we discussed about the advantages of using the custom functions, right? As part of the Power Query Editor. So what is the advantage of using the custom function? We can reuse a function. So the DAX formula is also right. You can use as part of the measures or calculated columns. You can use the DAX functions, right? Or you can use the formula. Once you store it in a column or once you store it in a, especially in the case of measure, you can reuse it. That is the advantage of reusability. So once you create a measure, you can use it for more than one visuals. Okay. The next one is that to create complex, customized formulas, very simple sum or average would not be sufficient. All the time, we cannot use the sum, average, or these kind of aggregation functions are not helpful in all the scenarios. And sometimes, right, most of the times, we will have to go extra mile, and it's not extra mile. Because of the complexity of the business logic, right? So with sum and average itself, we cannot implement all the complex logic. So why to use DAX? Okay. So this is why to use DAX. These are the scenarios, right? We need. So not all the situations, sum or average is sufficient. So so we have to go. We have to use many functions in order to solve these business use cases. Okay, business uses cases not all the time are very simple one or moderate one. It's a very complex one, complex and very complex one. That kind of situation, obviously DAX are very much helpful. Here, if you look at this, a simple example, like I said, a sum of sales, right? The financials table here, something called sum of sales. And in this case, on the left side, we can find the variable here, total sales, right? Total sales. And this is my equal sign. On the right side of the equal sign, we can find the sum. This is an aggregation function. Once once this value has been computed, the output of this one will get stored in total sales. Okay, the equal sign tells us, tells us the start of the formula and the DAX function, and then opening and closing parenthesis, right? So followed by the average, the aggregation function, you need to use this symbol parenthesis, and then either you can use a column or table references. So where are DAX formulas are used in Power BI? All these three places: calculated tables and calculated columns and measures. Okay, these are the three places where we use the DAX formulas. Okay, so what exactly the calculated tables and the calculated columns and measures? We'll take a look at it little later. Before that, let us understand few more fundamental building blocks, like or fundamental thing. Okay, so what is the difference between DAX and M language? And in truth, they'll ask you, what is the difference between these two? So here the question is, using Power Query Editor itself, I can create a new column, right? So why do I need to create a calculated column? The calculated column, I can create it using custom column in Power Query Editor. Okay. And what exactly the difference between the M language and DAX? Okay. So in that case, right, you should be able to justify them when you are supposed to use M language, when you are supposed to use DAX. And M language, yes, as I said, the learning curve is little bit more, but they will ask you what are the functions that you have used in M language. You can say table dot remove column, and then remove columns and rename the columns, right? So those kind of functions you can tell it out. And then yeah, so the difference is the M language is a query language. It is used in Power Query Editor. It's a very simple one. And DAX is an analytical data calculation language. But these two are completely independent of one another. Okay, so there is no, you cannot use DAX in M language and vice versa. You cannot, right? So you cannot do the same thing. With the opposite is also not possible. Now let us understand the DAX engine. Okay, the brain behind the DAX engines. Okay, the DAX formula is processed by two engines. What are the two engines? Formula engine and then storage engine. What exactly formula engine is all about? Okay, and what is storage engine? And how? So do I have to do anything in order for the DAX query to use the formula engine or storage engine? Okay. So first of all, the first thing is, that DAX queries, right? In the case of DAX formula, it is processed by two engines. One is the formula engine, another one is storage engine. Now let us understand the mechanics of, how the DAX formula is processed behind the scene by this DAX engine. Okay, the DAX engine is nothing but X velocity. Previously, it was called as a vertipack. Okay, vertipack. Now they call it as a X velocity. Okay. So whenever you write any DAX formula, right, that is processed by these two engines. Okay, the formula engine and the storage engine. In the case of both the import and direct query modes. Okay. Okay, so now the situation is, right, now let us understand the architecture. Okay, we'll take a deep dive in understanding how these DAX queries are processed. Okay, these two engines like formula engine and storage engine, these two engines work together to compress and encode the raw data and access the DAX queries. Okay. But first of all, what is the role of formula engine? What does it do? So in the Power BI, right, you will be writing a the DAX formula like this. Okay, using calculate function, you have written a DAX formula, and you have used a measure. The measure name is total revenue in Chicago. So this measure, you drag and drop it in a visual, or right, so table visual, or any other column chart visual also. So all we do is just drag and drop the measure which we created, like a total revenue in Chicago, into a table or into a column chart or so, right? The visual. So behind the scene, what happens is the query plan. So what happens is, sorry, not the query plan, the formula engine. The formula engine is responsible for accepting the DAX query, and then it processes the query and generates the query plan. Very simple. So he's the guy, you just think, the formula engine is the one responsible for accepting the query. Whatever you drag and drop it, it'll accept it. Okay, and then it processes this query and generates a query plan. Okay, so and then what happens is, in the case of import connection mode, the formula engine, what it does is, one second, this thing, oh yeah, the formula engine, 1 second. In the case of import connection mode, so the import connectivity mode and direct connectivity mode, right? Okay, in the case of import connectivity mode, the formula engine, it sends a data request to the storage engine. Okay, it sends a data request to the storage engine. Okay, because the formula engine cannot access the data directly. Okay, it has to depend on the storage engine. Okay, so what happens is, the formula engine requires the storage engines to give the data. So basically, it simply accepts the DAX query which has been written by us, and also it processes this one, and then it generates a query plan, and it requires the storage engine by sharing the query plan to this storage engine. So upon receiving the query plan, the storage engine, what it does is it returns the vertipack or the X velocity data cache. It returns this one. Okay, I just use this one. Simply, it's something like, you are asking a query with the front desk guy. So what he does is he doesn't have the data or the answer for your question. So he has to depend on other guy. So before defending this, what he does is he's, kind of creating some kind of query plan, and he share it with him. So upon receiving this one, right, he goes one step further and then returns the data that was requested by formula engine. And this one will be, sent back to your visual. That is what is happening. So now the question is, what is vertipack, or what is X velocity? The latest name is X velocity. What is X velocity? It converts your table or data into columnar data. There are three task performed by the vertipack. We convert the tabular data into columnar data. And what else? What is the second step? What is the second step? How many of you have gone through my videos? What is the second step? Convert tabular data into columnar data. And second step is it compresses the data. Compresses the data. What is the third step? What is the third step? It loads the data in memory. In the intro, they'll ask, a couple of my previous batch students, right? They said they asked about DAX engine, how it works, the mechanics of DAX engine, X velocity, how does it work? What is the role of X velocity? The X velocity engine will get started, or it gets kicks in, right? So as soon as or in the case of import connect mode, this one will get started behind the scene, the X velocity engine. Okay, the X velocity engine does these three jobs behind the scene. Okay, but in the case of direct connection mode, the formula engine, what it does is sends the SQL query directly to source database. In the case of direct query mode, it is not using the X velocity engine is not coming into picture. Remember this, X velocity is not at all coming into picture in the case of a direct query. Only in the case of import mode, the X velocity engine will get started, and then right behind the scene, this one will get initialized. And then what it does is it does these three jobs. When it comes to direct query, the formula engine generates the SQL query. That one will be sent directly to the RDBMS data system. It could be SQL server or RDBMS, sorry, the SQL server or Oracle or any other RDBMS. In that case, whatever the query will be sent directly, to your SQL server database. In this case, okay. So the result set of the query will be sent back to your formula engine directly. Okay, in the case of in-memory, right? In the case of in-memory, what is in-memory? The import mode. Okay, in-memory. This is your in-memory. The X velocity loads the data in memory, right? In the case of in-memory models, the imported and compressed columnar memory cache is your storage engine. The imported and compressed columnar memory cache is the storage engine. Okay, so you just think that, or instead of complicating this way, you just think in a simple aspect. So upon receiving the DAX query, formula engine, it processes it, it accepts it and processes it, and then generates the query plan. Now you might be wondering, what is this query plan is all about? What is query plan? Any idea? Query plan is something like you just think about your Google map. If you want to go from one point A to point B, you have n number of routes are available. So what you do is you use your Google map, and then you will ask, right? So from this is my source and this is my destination. How do we go that? It gives you 2 or 3 routes. Whichever route you prefer, you can do. So in the case this, and then what you do is, when you look at the Google map, so whichever route is the shorter distance, you will prefer that one. Okay, let's say point A to point B, there are 3 different routes are available. But compared to this one and this one, okay, this one is shorter distance, which means it will fetch the data in a much faster way. It's something like a query plan. Okay, it's a query plan only. If you know the RDBMS SQL performance tuning, then you might be knowing the query plan. How many of you are aware of the SQL query tuning? So in the interview, they'll ask you that one also. Okay. So what is query plan? So when it comes to DAX, you have single logical query plan and physical query plan. Okay. I'm not going to get into that much of detail now. At this moment, formula engine, before requesting your the storage engine, it converts your query into query plan. It generates a query plan. Okay. Your query, right? It first assesses it and checks any syntax error, anything. If nothing is there, everything is good. Simply it parses this one, and then it generates the query plan. This query plan will be sent. Hey, use this plan to access the data and retrieve me. Okay. If you follow this plan, the retrieval time will be much faster, something like that. But in the case of direct query mode, the query plan will be, the query will be directly direct query. In this case of direct connection mode, The query will be sent directly to SQL query. The output will be sent back from your SQL server or any RDBMS to your formula engine, and this one will be populated in your visual. That's it. Okay. So reads the data source and transforms the data into columnar structure and encodes and compresses. Yes, here the encodes. I don't want to use this term, at the outset itself. So encode the data and then compress the data. Before compressing, it uses some kind of encoding technique. Okay, when you do encoding, what it does is, in simple term, it reduces the spaces. Okay, it reduces space and then it does the compressing. Okay, so now we will take a look at what exactly encoding. So there are different techniques are available as part of encoding, which we'll see it little later. So in the key and the rights, and also it establishes dictionary index for each of the columns for different type of the data. It uses different encoding technique, which we will take a look at it in a little later. So this is what I discussed. If you work with a direct query, you cannot use the Wetipack or the X-Velocity engine. It is not using it behind the scene. Okay, the X-Velocity engine can only be used for import models using the import. The interview they ask you about this one, you should be able to remember this. Okay. These are the steps I explained. In the case of import connectivity mode, these are the 3 steps that are happening. Reads the data source, transfer the data into columnar structure, encodes and compresses the data within each of the columns. And some data types, it uses the dictionary and index for each of the columns, and it prepares and establishes the relationships. Okay, this is what the X-Velocity engine does. X-Velocity engine or the Wetipack engine does. If you say you are a 4-year experienced person, you should be knowing the name for these 2 engines. Okay. So, okay, what is the columnar database and tabular database? Why it has to convert the tabular data into columnar structure? We discussed already. How many of you remember it? Why, in the case of import connected mode, why X-Velocity engine converts your tabular data into columnar? Nitesh.
To access the record fastly from the table.
Okay, to access the record in a faster manner. So,
Yes.
so can you make it little bit in detail?
In the case of the if we have a table, there are let's suppose that 4 columns, and if you want to access the 4th column, then in the case of not in the normal case, it will first check the 1st column, 2nd column, 3rd column, then it goes to the 4th column.
Correct.
But in the
real-time scenario, in the real, very good, right? Nitesh is very good. Okay. So what, he conveyed it very clearly, right? So he made it crystal clear. For example, I have 100 columns are there in my given data set. I don't want to, use all the 100 columns to create a, report. So let's say my manager asked me to create a report. So to create that report, all I need is just 4 columns. But that 4 columns are not available at the beginning itself. Okay, so it is available. Some columns are available in the 50th column position. The second column is available in the 60th column position, and so on. Okay, it is not sequentially stored, and also it is not available at the very beginning of this table data set. Okay, it is we need to scan. So what happens is, in the case of row based, it goes each and every column. First column, it checks whether the first column is the region column. For example, you wants to see the region wise, quarter wise, units sold and units. Okay, units sold and the sales. Okay, only these 4 columns: region wise, quarter wise, unit. These 4 columns, he wants the data for these 4 columns in the report. You need to show the output of you need to show the in the report you need to display the values for these 4 columns. But in the given data set, you have 100 columns. What happens is, in the case of row based, it will go and check the first column is a region column or not. No, it is not. That it keeps skip it until it finds the region column. It keeps on checking it. it takes a lot of time, especially if you have 50 million records in your data set, right? Each and every row, to until it finds the required column. If it skips the columns, it will literally slow down the performance. Okay, so in the case of columnar database, they store each column separately. Okay, in the case of table, they keep the entire all the columns in a single table. The columnar database, each column will be stored separately. So that what happens is whenever you fire any query, what are the columns that are there, right, in that query, that specific column related data will be accessed directly. Instead of skipping each and every column to find the required columns or the specified column, it goes directly to the column which you wanted to use it in your report. Okay, that is the reason why it convert the tabular data into columnar data. And then the second step is, okay, if I convert in the columnar data, column level it accesses, hence it is faster. Fine. To access the 4 columns data, you need not to scan each and every column. Go to these 4 columns directly, because we store the data behind the scene. What happens is it store each and every column data separately. Fine, this is very good. I don't have to scan each and every column because the volume of the data is 500 million. Each and every row, if I do it, it takes a lot of time. Okay, fine. Now it converts the table into column. Second step is it does the encoding. And then what it does is within these 4 columns, whatever the data are there, it tries to compress it and reduce the data. If you have 8-bit data, right? Roughly speaking, 8-bit data, what it will try to reduce to 4-bit. So that your storage space will get reduced. You don't have to have too much of storage space. Okay, you compress the data. Now what we do is if you load this compressed data in memory, the performance will be much, much faster. And also it doesn't require too much of memory space. Okay, so for that, okay, now you understood what is columnar and why it has to convert the column into tabular data. In the case of the import model, this one, the X velocity comes into picture. It does these 4 things. Okay, now let us understand the compression encoding technique. Okay, so what technique it uses to do the encoding? What is the goal of doing this one, right? So it is to reduce the amount of memory required to process a query. The VertiPack stores a compressed copy of the data in memory. That is what we discussed. There are 3 types of encoding. The value encoding, and the other one is dictionary encoding, and third is run length encoding. So what is value encoding? It is used on integer type of the values, integer data type. For example, you have quantity and you have some quantity or some other columns, right? Those are numeric data type which are in integer data type. The value encoding is done. And dictionary encoding is done for text data type. And run length encoding is used for repeating values. It codes a column that is value encoded or dictionary encoded. Okay. When in the case of run length is it's kind of an hybrid. The value encoded or dictionary encoded. Okay. So what is value encoding? Now we will take a look at what exactly value encoding is all about in detail. Now we'll take a look at it. So this is the given data set. Okay, this is the given data set. Okay, let's say you have some quantity column. What it does is, in the case of value encoding, the X velocity engine, right? What it does is, it subtract the minimum value from all the values of the column. So what is the minimum value here? Can all of you please type it in the chat? What is the minimum value? Which one is the least value here? This is the one, right? The 194. So it first finds out the minimum value, and then it subtracts the minimum value from each and every value of this column. Okay. Okay, it subtracts the values from all the columns, the minimum value. Okay, so that it can modify the range of the column. So what happens is when you subtract this one each and everything. See, if you look at the range of the column, what is a range in statistics? If I say range, I mean the minimum and maximum. Sorry, the min or the difference between max and minimum. That is what your range. Okay, so here what is the minimum? 194. What is the maximum? Yeah, max min minus min, right? So who said that? Prabhat, okay. And yeah, max minus min is your range. So what is the minimum here? The 194, and then your maximum is your 214, 216. This is your maximum. This is your minimum. This is your maximum. Okay. But when it does the value encoding, what it does is it subtract the 194 each and for example 292 minus 194. Sorry. Am I audible to you all? So there are some, there is some noise coming here continuously. Yes, I'm audible. Okay. Am I audible now? Is it audible? Is it audible?
Yes, sir.
Good, good. Thanks. Some noise is coming. I don't know. I think some keyboard or something is touching because I'm not using a table. Okay. So that's the reason why. Okay. Sorry, guys. We'll continue. So in this case, there is a reduction in space. If you use this algorithm or technique by subtracting the minimum value from each and every value, what happens is it will reduce the size, they reduce the size of these values. So even if you have the maximum value is 22, but your minimum value starts from 0 and max value is just 22 only. In this case, to store these values, it requires just 5 bits, whereas in this case it requires 8 bits. It requires 8 bits. You might be wondering, so the just 3 bits saving just 3 bits, how it is going to make a difference. Obviously it will make a difference in the case of huge volume of data. If you have 100 million records or 50 million records, right, each record, if you save 5 bits, 5 into your 50 million record, right, you are going to save a lot of space there. Okay, so this is one technique is used to the compress the data. And next one is the hash encoding, the value encoding. The second one is the hash encoding. This is used on the text values. In the case of number data type, it is fine. In the case of numeric data type, the text data type. So what can I do? So hash encoding. So what it does is it builds a dictionary. In the case of hash encoding, it builds the dictionary. The dictionary will have the distinct values of the column. Distinct values in this and the unique values. Red is repeating only one time, it will appear. White, black appears more than one time. Blue, even though these values are appearing more than one time, it will consider only the distinct value. In the sense, the unique values. Just to give me, it's kind of annoying. What process this one? I don't know. I don't know. Yeah. Today I'm running into a lot of confusions. Okay. So in the case of hash encoding, it uses a dictionary. So okay, it creates the dictionary. The dictionary it will keep only the unique values of your text columns values, red, white, black, and then it assigns the unique value for each and every text value. 0 is red and 1 is for white and 2 is for black, 3 is blue. So once this dictionary has been built, the next step is it will replaces these values based on so it replaces these values by the unique IDs. Wherever red is there, 0. So we know very well when you refer this dictionary, okay, 0 is nothing but red. And it's kind of a lookup table, okay? So 0 is red and 1 is for white. Wherever you see 2, those values are related to black and 3 is related to your blue. You understood, right? So in the case of text data set, hash encoding is used. In the case of hash encoding, builds a dictionary. The dictionary will hold the distinct values. For each distinct value, it assigns a unique value. That unique value will be replacing the text values in your actual column. So in this case, also look here, if you compare these values and this one, right? So end of the day, your column will have only these type of values. So in that case, it will obviously save a lot of space. The next one is run length encoding. It is used to look for the repeating values. The classic example, this is a quarter. You have a column called quarter, Q1, Q2, Q3, and all is there. Q1, Q2, Q3, columns are there, values are there. And if you see the Q1, it appears 310 times and Q2 appears 290 times. 290 times. So what happens is it builds a dictionary. Okay. So in this case, it builds a dictionary and then okay, what happens is here, look here. So it builds a dictionary. So in this column, what are the unique values? Q1, Q2, Q3, Q4. And for each distinct value, it assigns the unique ID. And then this value will be replaced in place of Q1, Q2, Q3 and all. So wherever Q1 is there, it puts 0, 0. Okay. And then this is your dictionary encoding. That is what we discussed a while back. That the hash encoding. Hash encoding is also called the dictionary encoding. In the case of text data set, you'll be using it. But in the case of run length encoding, what happens is, if you see here, the quarter, the same thing, the table, and then the data rows. And the data rows are something like, something like Q1, values start from 1 to 310, Q2 311 to, look here, this is the Q2, right? So the 3 up to 310, so 1 to 310 is Q1, and Q2 311 to start from 311, and then the rest of the values, okay? Count is 290, start from 311 and overall 290 values are records are there. So here what happens is 310 and 290 and then you have something called 425 and then 350. Okay, in this case what happens is okay, the Q1, Q2, Q3 and the values here, if you see here, okay, 310 here, 310 is right. First 310, it replaces that with 0. Okay, the remaining 300 to 290 records values, right? That will put 1. Then the remaining 425 records, it will put this one. Okay, you have Q1, Q2, Q3, Q4. Q4, 350 values are there. Okay, for that it assigns this value. It uses the combination of the dictionary and then the this one, okay, the count, it uses the count. Okay, 300. So here, if you see here, 0 is Q1. Q1, how many values are there? 310. How many number of times Q1 is repeated? 310. How many number of times Q2 is repeated? 290 times. How many number of times Q3 repeated? Occurring more than once Q3? 425 times. So this is how it works. It works with the combination of the dictionary as well as the encoding technique. Okay, in the case of run length encoding. Okay. To summarize, DAX uses two engines. That is what we have seen: the formula engine and storage engine. The formula engine interprets and evaluates DAX, and the storage engine compresses and encodes the data. The responsible storage engine is compresses and encodes the data. And then what is the role of the two types of storage engine: X velocity and direct query. Storage engine itself, there are two types. Okay, X velocity and direct query. In the case of import, X velocity will get started, kicks in. And in the case of direct query connectivity mode, direct query will, that storage engine will get started. Okay. The vector pack stores the data using columnar database data setup, and the raw data is compressed and encoded to optimize processing. Okay, so it converts the tabular data into columnar data, and then compressing. To compress that, it uses the techniques like the value encoding in the case of integer, numeric data type, and in the case of text, it uses the hash encoding. And in the case of run length, repeated values, run length encoding, RLE, run length encoding technique it uses. What are the data types that are available in DAX? These are the data types: the whole number, decimal number, the currency. Currency is nothing but the fixed decimal number, and the date time. Okay, and the whole number is a 64-bit integer value. It is stored as a 64-bit. Almost all of them, right? But here it is integer value, whole number. In the case of decimal number, it's a real number. Okay, and the ranges are between these two integer values. You can store it anywhere between this and this, and then the negative numbers between this one and this one, 0, and positive number between these two values, you can store it in the case of decimal number. These are the range of values you can specify. It's all too big number because we are dealing with so about now. Am I audible? Is it audible? Okay, fine. So the addition and the subtraction, multiplication star, and then division, this one, and then the caret is for exponentiation. If you want to take these, exponentiate of, if you want to exponentiate this one, right? So you can use caret. And then comparison operators, equal, single equal sign. If you want to do some kind of condition, right? If condition, if you are using an if condition, you can use this equal sign. And if you want to, you want to compare exactly equal to, double equal sign. Okay, and greater than, less than, and greater than or equal. These are self-explanatory. And then the next one is the logical operator, double ampersand sign and pipe symbol in functions. Supposing you want to check like this, the channel name. There is a column called table called channel. In that we have some channel name. In this column, I wanted to restore only these three values. Okay. So what are the values? See, in the channel name column, I want to retrieve the records that are relevant to these three channels only. Okay, in that case, you can use in operator. In SQL query, will be using in operator, right? The same thing we are using it here. It is same as your SQL query is in operator. What happened? Someone said yes. Okay. And then the next one is the logical functions. If error, in, not, or, switch, true, false. These are kind of your logical functions, and using which you can, you can write the if-else conditions. Using if error, you can handle the error. Okay, you can handle that. In case of any error, you replace it with some value, so that your your visual will not get disturbed. It will not throw any error. Okay, in, not, or, switch, true or false. Next one, the information function is blank. If you want to check whether a given column is having any blank values in it or empty values. Okay, so the difference is the is blank, and here I mentioned is empty, the table expression. The only difference, you can use the expression here, whereas is blank, you can directly specify the column name. Is logical, is that a Boolean value? A specific column has Boolean value in it or not? That is what you can check it. Not audible. Hope it is audible now, right? So whenever you see this message, you should be able to hear it. Am I audible?
Yes, sir.
Yes.
Okay, fine, thanks. Sorry guys, it will be a bit annoying because I have to travel official trip. I cannot say. So that's why all these confusion. So anyhow, though I checked it multiple times, right? So since I'm using the table here, it is not that much helpful. Variables in DAX, how do you define a variable? There is a reserved word called variable where, and here followed by that we specify the variable name, and followed by that equal sign, and then followed by the equal sign we specify the expression, and then we return the expression. Okay, here anyhow we'll take a look at the variables a little later. Okay, the logical function, switch function, I will show you how to use that little later. Now what we will do is we'll directly jump into the type of DAX functions that are available. Okay, so these are the important types of DAX functions you should be learning, you should be knowing about it. Okay, the aggregation function, round function, logical function, information function, date time, and so on. So what we will do is we will start with I'm going to just skip this one a little bit. But don't worry, I'll be covering everything. Okay, so okay, we'll start with understanding the aggregation function, the count function. Okay, so these are the types of count functions that are available that are available in DAX. The count itself, we have seven different types of count functions are available. Count function, count a function, and then you have something called count ax function, and then the count x, count blank. These are the functions are available. We'll quickly take a look at these functions now. So what is a count function? What is a count function? Count usually, right, in all the language, the count function is available. The count function counts the number of values in a column, okay, that contain numbers or dates or strings. Numbers, dates or strings. Look here, I have categorized these 7 count related functions into 2 categories. These count functions excludes the blanks. When you use this count or count a or count x, count ax, it excludes the blanks. Okay, supposing number of values in a or a column excluding blanks. Let's say you have 10 values are there. Out of the 10 values, one value has blank value in it. When you use a count on, let's say a count of quantity, right? So what happens is it excludes the blank, and then how many number of values are there in the column. In a quantity column, you have 10 values supposed to be there. Out of the 10 values, one value is blank. In that case, it will simply ignore that blank value, and then it will tell you only 9 values are there. That is what your count function. The count function count the number of values in a column for number, date, and string data type. The count function, it does not count blank values and the Boolean values. But if the Boolean values are there along with numeric values, it counts it. Okay. And categorical data, it will count. Okay. But only Boolean value, it will not count. If you have Boolean value, true or false, you cannot use count function. If your column have true or false, you cannot use count function. It excludes the blank values. It gives you the number of values in a column. Okay, it is not doing the sum. It is not doing the sum or total. Simply it checks how many values are there in a column. You may be having 100, 1,000, 1 million, but it doesn't, look at, the number of digits. It simply check, how many, let's say you have 10 records in quantity column, how many values are there? No, the 10, instead of 10 values, we have only 9 values are there. The one specific record, we have a blank value in the quantity column. Right, so count A, right, so it counts the number of all values in a column, including text. Okay, number of values in a column that contain number, date, strings, and Boolean. The difference between count and count A. So as the name suggests, the simple way to remember is count A, all data type. What are the data types? Number, date, string, and Boolean values. For these 4 data types, it counts the values in a column or in values in a cell. Next one, the count x. Count x function any function in DAX that ends with X, these are all called your iterator function. It iterates row by row to perform any kind of arithmetic operation or calculations, right? Any function that in DAX that ends with X, count AX, count X, these functions are called iterative function or iterators. So now the question is, what is the difference between count X and count? Okay, the count X, in this case, you can use the expression. Okay, whenever you see the function that ends with X, that is called iterator function. And in this case of iterator function, you can use the expression. Instead of performing a count on a single column, you can do some kind of arithmetic operation, or you can do some kind of filtering, and then you can perform the count. Okay, and the next one is count AX. Okay, before we jump in count AX, count AX, what exactly the difference between the count X and count? Count X, you can use expressions, whereas in the case of count, you cannot use expression because you can use only one column. Count X, you can use an expression. Even in the case of count X, you know, it doesn't count the blank values. Okay. And also it is not counting, it excludes the Boolean data. It will not work with the Boolean data. Which one? The count X function. The count AX also somewhat similar to, it's similar to A only, all data type. It works with all the data type. Since it ends with the X, it's an iterator function, you can use an expression. Okay, instead of using a single column, you can use an expression itself in the case of this one. The next one is self-explanatory, distinct count. I want to find out how many distinct values are there. It includes the blank values also. Count blanks, as the name suggests, how many number of blank values are in a column. Count rows counts number of rows in a table. Count rows gives you total number of records in a table. In the interview, they ask you, how do you find out the total number of records in a table? You can use count rows function in DAX. Or the other alternatives in the case of data view, on the left bottom corner, we can see the number of records. In DAX, count rows, we can use it. 1 second, let me just open Power BI desktop. I have something called count function. Yeah, this is the one, count family demo. If I reuse this report file, I can expect in a pretty fast manner. And it's a very simple function, it's very easy to remember. Otherwise, I'll have to load the data. It's time taking one. We will use this one. This is the latest one, 26/3/2022. It is loading. So this is the data set I've used, it very simple data set. Sales by customer, okay. And this data set already I used it in the case of Power Query Editor. Okay, hope you remember this. So what I did, instead of going to the data every time to check what values are there in each and every column, I created a table visual and then I dragged and dropped all the columns into table visual. Okay, all the required columns. Okay, what are the columns that are available in the table? Okay, these are the column, business columns. Okay, here I have used I just duplicated this column here, column customer again. I'll tell you why. Okay, why I did it. Look here. Okay, this column is not required. Let's not worry about it at this moment. Okay, so the count function will start with understand what is count function. Look here, I put count function here, right? If you select this, it's all chord visual. I just selected this one. And then if you see here on the right side, count of sales, this measure got highlighted. Count of sales by customer sales. Look here, look at this sales column here. If you look at this sales column here, 1 second here. How many values are there in the sales column? Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values supposed to be there. But in sales column, we don't have 10 values here, right? So you have blank value here, blank 2, 3, 4 blank values are there. 10 minus 4 is 6, right? That is what it shows. Pretty straightforward. So 6 values. So it excludes the duplicate values. Now you understood what is a count function. Okay, and we have true false values are there. What I do is I just copy paste this one here. I just keep this somewhere here and I just take this function count of sales M to check the statement made by me is correct or not. So what I'm going to do is I'm going to create another measure. I'm going to do a count on this active column. Active column is a Boolean data type. The sales column number data type, unit sold is a number data type. Look here, the count function is not working with the Boolean data type. Okay, it works with number, date, and string. Remember that. Okay, in the case of Boolean, it will not work. You cannot use count function. Okay, what is the next function? The next one is the count A function. Count A, look here, the measure name itself has given the count A function. Okay, count A. You can use it for all data type. In this case, I've used the text data type, customer. In the customer column, how many values are there? 10 rows are there. 10, since the count A function also exclude the blank record, excluding this blank record, remaining 9 values are there. That's it. Okay. And if you want to see the formula that I used, select this card. And if you see the right side, you will find the measure which will get highlighted. Look here, the customer count A function, customer column. Okay, the table name and column name. Okay, the count A, now you understood it works with all data type. And then the next one is the count X function. The count X measure, what I did, I used the expression here. In the case of iterator function, you remember that the first argument is supposed to be table name. Okay. So in the previous case, the count function, right? So what we used, we just use this one itself, customer name or the sales column. Just specify the table name column, that is enough. But in the case of X iterator function, the first argument should be table name, comma, the table name, and then the call a customer's name. The count X, this I used on customer's name column, but it shows 10 values here, 10. So why does it shows 10 here? Because it is a text data type, right? Text data type. It considers the blank record as a empty string. That is the reason why it gives us 10. So according to this, all these rows have blank values in it, including this one is okay. It's not considered as a blank value. It's an empty string. Okay. Since 10 values, okay, 10 values are there. Count X measure, count AX. Count AX if you see here. Count AX is also similar to count A, all the data type it will work. But since it's the iterator function, X, because it ends with X, it's an iterator function. It row by row, it performs it evaluates your expression. In this case, the first argument is supposed to be a table. Okay, instead of specifying the table name, I've used a function called filter. This filter function returns a table. Okay, the output of the filter function will be a table. Okay, again, the filter function takes the first argument as a table name, comma, the expression. I've used the expression. Don't count all the values. What you do is you count all the customer whose status is active. Okay, likewise, you can use the expression. So filter function is very much helpful to filter the values. You can use a filter function inside the count X function. Sales by customer, something like that. Okay. So here, what is the outcome? We are getting 3. So why are we getting 3 here? Count AX. Can someone tell me quickly? Active, it goes by this column. In this column, we are doing the check. Active equal to true. How many you exclude this one false, right? Only 1, 2, 3, 4 records you have true values in it. Okay, and then customer column we need to do the count. So 1 and 2 and 3, and here it is not considering it. Okay, in the case of count AX, right? It ignores the blank value here. In this case, in this case it was the customer. Okay. I did not use the customer's name column here. 1 second. I'll just show you the difference. Look here. Instead of customer, I have used the customer's name. If you exclude the false, rest of them are true, isn't it? Rest of them are true. Active sales by customer act. So I'm filtering on this column. Okay. I apply a filtering condition on this column. Okay. After I apply the filter, I will end up only with 4 records. True, 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 true. And then I'm just checking the customer name, right? The corresponding values 1, 2, 3, and here I have blank value. Like I said, in the case of text data type, the blank value is considered as a value only because it's an empty string. So hence it shows 4. But in the case of the customer column, this is a duplicate of this one. But when I use customer column, it shows 3. Why? It's a duplicate of customer's name, but it shows 3 here. Same condition, everything is correct. The value is also same, but it shows 3. The reason is if you go here, sales by customer column, if you selected, you have the customer name, unit sales, sales active, right? So, and then customer. If you look at the customer column, I have used an if condition here. If this column has an empty string, the blank value is nothing but empty string, then you replace it with blank function. The blank function will return a null, NA, okay, null here. And then if you don't see any null string, then you display the same value as this. It goes and checks Okay, in this case, what happens? It goes and checks barren. In this column, do we have empty string? No. In this column, is this condition true? No, right? Hence, it displays the customer name itself. It comes here, there is no blank, here empty string is yes, equal to double, don't leave space here, okay? Double quotes, no space, double quotes. That means empty string. Okay. Yes, it is an empty string. In this case, you replace this, instead of putting the empty string, you put blank value, null value. That is the reason why here it displays 3. Because in this case, what happens? The true is 4 records same, barren, and 22. This one, but since we have replaced the empty string by blank, count AX function excluded the blank value. Got it? That's all. So the count function exclude the blank values. Count AX, count X also exclude the blank values, but count and count X function does not take into account of the blank value. Sorry, it does not work with the Boolean data type. These two will not work. So look here, this is the error. Okay, count and count X will not work with the Boolean type, whereas count X and count A work with all data types: number, date, string, Boolean, all the data type it will work. Okay. In the case of text, you need to remember this one. That's why I've used this column here. Okay. And count AX, I have used here I have used the filter condition. Okay, instead of using count AX, see, it's a iterator function, sales by customer column. Again, column name alone, if I use it, is a plain vanilla, right? So anyone can do this one. So, but to show you the differentiation, I have used the the filter function as part of the count AX. Okay. You can use a function inside the other function. Okay, the DAX. And the next one is the blank count. How many number of blank values are there? So here, let us check which column you are checking it. Customer's name. This is the conflicting thing. When I use count blank, I just sent a the note about this one to the Microsoft. Okay, the blog, the Microsoft, but I'm yet to receive the response. When I use the blank count function, count blank function, it tells me that this customer name column have one blank value here. But whereas if you look at this one here, it doesn't it doesn't consider the blank value as a blank value. In the case of text data type, it considers a blank string, right? Empty string. But when you use a blank count blank, it literally considers a blank record. That's all. Only one blank value is there. Fine. The next one is the blank count. The same thing. Okay. The blank count sales column. How many blank values are there? 1, 2, 3, 4. Yes, it shows correctly 4. Count blank. In the case of number data type, count blank is working fine. The text data type is little bit confusing. And the next one, the count of sales already we discussed, and the number of records, count rows. Count rows, but count rows takes the table name. You cannot use the column name. As the name says, count rows, right? Count rows for the table, not for the column. Okay. So how many rows are there? 10 rows. It takes into account the blank value also. Okay. And here, yeah, that's all. So the count blank function, we have seen it. And then what else? Distinct blank. Distinct count. Okay, we have something called distinct count, blank count, and distinct count. Distinct count distinct values in a column, including blanks. Okay, so that is what it does. Let me do one thing. I will put that one also here. Okay, I will use this chord visual. 3. So in this case, 1, 2, it takes into account of blank values also. So how many distinct unique values? True is though it appears more than one time, it considers only one time. False is considers second one. Third one is the blank value. Okay, distinct is unique values. Not it will not count each and every value. Okay, so that is what distinct count. This is your distinct count, and this is your count rows and count blank. It gives you, it's pretty straightforward. How many blank values are in column? You can use this one. Hope you understood all these functions, count related functions. Okay. The interview they'll ask you like what is the difference count and count a function. A is count a function. You can use it for all data type, number, date, string, integers. But it excludes the blank values. Even the count also excludes the blank values. But count works with only the it works with all the data types except the Boolean data type. The count X also same as count, but here you can use expression. Like I've shown you the filter function, right? You can use a filter function inside the count X function. And count AX also you can use the filter function. But count X and count also same thing, but here you can use an expression like a filter, the table name, comma, the customer type equal to active or inactive, something like that. You can use some kind of expression as for filter function or expression. You can use it. Count X also you can use it. The count AX, count are same, count X and count are same. But only thing is the functions that end with X are called iterator function. In this case, you can use the expression. Hope you understood the differences between all these type of functions.